morning. Thank you very much for coming. It's always a great pleasure to be here at Devnexus. And today we're going to try to discuss from imperative to reactive programming. My name is Edson Yanaga. My Twitter handle is @Yanaga. And just introduce some fun facts about me. Most people are surprised by that, but I'm a Brazilian Japanese, and not the typical Brazilian, but I was born and raised in Brazil. I'm also a Java champion and a Microsoft MVP. As far as Google can tell me, I'm still the first and only one. And the purpose of this talk is because I decided to give this talk, and it's the first try from my experiences of trying to blend this both words from imperative to reactive, is that a lot of people are talking about reactive systems, reactive manifesto, reactive programming, reactive streams, operators, and all things reactive. But it was very hard for me to try to grasp, okay, but what about my code? So what I want to try to show you today is maybe how can we get the code that we're used to programming and translate that into some reactive primitives so it can be run by a reactive engine so we can get the benefits of reactive programming without digging into that lots of theories like, oh, my system needs to be this or to be that, to have these properties. No, I just only interested in the reactive programming part as a developer. So how can we achieve that? As I said before, these days we have React of the things, a lot of people talking about reactive, a lot of people writing about reactive, so we have reactive books, and the discussion starts, oh, I want what type of reactive, what kind of reactive, do I need to be reactive? These are very good questions. I still believe that reactive systems or reactive programming, maybe it's not mainstream, but it's super useful for some niche use cases, and I intend to show some demos for you to be able to realize which scenarios benefit your application or not. So I mentioned before, we have at least, that's the things that I was able to collect on Google. When we're talking reactive, people talk about reactive systems, reactive manifesto, programming, reactive streams, and extensions. And they all mean different things. They're applying different parts. They all have different definitions. But if you type reactive, that's the stuff you find when you're Googling that on the internet. So that's why it's super confusing. So we're only going to focus on the reactive programming part. So when I decided I want to be a reactive programmer, I want to write reactive code. So let's try to find a definition so we can have some common ground to be discussing how to do reactive programming. So the first try was on Wikipedia. So I went to Wikipedia. They have a very nice warnings about the content. But then I started reading on Wikipedia, saying if you try to get the definitions, well, reactive programming is a declarative programming paradigm concerned with data streams and propagation of change. And if you go further, they'll show the example, well, reactive programming is like programming on a spreadsheet. Whenever you change something on a cell, it will be automatically reflected on another cell, which will have some computations, which is very nice if you're programming in tools like Visual Basic, Delphi, or something like that, where you can have some triggers. Oh, when I never change this, I want an event to be changing that. But how do I translate that to my Java code? Well, I couldn't understand at that point if or when this will be applied to my Java code. So let's try to have another definition of what is reactive programming. So we have a lot of people in the back, so if we're sitting and you have an empty seat, if you could just compress. I know younger people don't know what is compressing the disk, but that's when you like fill up some empty spaces. Thank you. So another definition of reactive could be the reactive manifesto, which is much bigger than that. I only speak it as small parts. But when you look at the reactive manifesto, you see that they're discussing a lot. Oops. But the most important, okay. I just want to emphasize that they're discussing about reactive systems. And they describe some properties, for example, reactive system must be responsive, resilient, elastic, and message-driven. So maybe they're not talking about the code, but the properties of a lot of components that compose a system. So it's not reactive programming. So I couldn't find a proper definition of what is reactive programming, but my conclusion until now from all that I read about reactive programming is that applied to Java code at least. Reactive programming is programming with asynchronous data streams. So if you have asynchronous data passing between each one of your methods or invocations, it doesn't matter if you're using a library or not, like between each one of your steps of your computation, if you're controlling the flow with asynchronous data structures, with asynchronous data streams, we'll go dig into that further, then you're doing reactive programming. And for this to become, for your reactive programming code to become a reactive system, to exhibit that properties to be resilient, fault tolerance, or all of this, it's also the requirement that this reactive programming must be built on top a non-blocking platform. So it needs to be async. You need to use data streams that are also async, and you need to program that on top of a platform that is async and also doesn't block. Okay? What means doesn't block? Well, you can't write to a file and wait for that I/O to complete. You can't read from a database and wait for that query to complete. You can't write and wait for a log to be available. Everything needs to be async. So basically, you're not waiting for anything. And reactive systems that we're trying to design with reactive programming are super useful in applications that are I/O bound, which is most like what most web applications we have today, they are. They're not CPU bound, like you're not constrained by the amount of CPU that you're consuming, but usually you're constrained by the amount of I/O that you have to wait to service your client's requests. So that's the problem that we're trying to solve. If you want to scale, you want like, people say web scale. I think it's more than web scale, because if you have 1,000 users, okay, maybe it's web scale. When you want like hundreds of thousands, millions of users to be served by the same service that you had before, then maybe it's the kind of scale that you want with reactive programming. And now that we have like, we're all tired of paying like very expensive AWS bills, maybe we want to save some cloud computing costs so we can do more with less. No, maybe it's nice for you to be using reactive programming. And we still have a couple of seats here on the left side. And I don't want to just to be talking about how to do reactive programming. I want to show code because that was the goal of the talk. And I want, of course, I have to use a disclaimer because I'm going to use my favorite framework, a framework that sparks joy. And how many of you know Maria Kondo? A few people, again. I asked the same question in Japan, and I was expecting everybody will raise their hands. Nobody. Nobody raised, okay. Nobody knows who is Maria Kondo, okay. But Maria Kondo sparks joy is that there are some stuff that if it doesn't spark joy in your life, you just thank and leave behind. And the feeling for Java applications, for example, in this particular case, having to wait for, life is too short to wait for application server to restart, okay? That's why we're going to use Quercus for all of these reactive demos. And why did I choose Quercus? Well, because Quercus, besides being super fast and have this library load feature that I want to show you, Quercus blends a lot of different frameworks and paradigms in one single framework that has these capabilities. It's super fast, super small, and with library loads. And the ones that we're interested about is that with Quercus, if you want to code the traditional way, imperative way, blocking way, you can with the APIs that you're familiar with. But if you want to mix on the same class one method that is reactive and the other one that is imperative and blocking, you can. And that's what we're going to show. Just for the sake to be honest, Quercus right now, for the database part, I can only create one data source per application. So for my application to be truly reactive, I need a reactive data source. And for this, because of this issue, we will have two separate applications. One will use a reactive data source, and another one will use a traditional data source, right? Let's start with the imperative one, because we will use the source code of the imperative one to migrate to reactive. So I'm going to my new favorite website on the internet, code.quercus.io. If you ever use any generator, you know what I'm talking about. Code Red Hat developers, com Red Hat developers, and it's going to be the imperative one. And I want to use some extensions. For example, I'm going to use MariaDB. I also want to use Panache for my persistence. and I want to produce some JSON. So rest easy JSON B and generate. Should be good. We can always add more later. So I just saved this one, and let's go to my terminal. So we're going to unzip imperative. Now I'm going to open my favorite IDE, Visual Studio Code right now because it's super fast to start, and I'm using the Java plugin developed by Red Hat too. Disclaimer: I work for Red Hat, but you might have been aware of that already. Okay, so I have here. REST resource is just synchronous, so I'm going to start the magic. I'm going to type vn Quercus :dev. This the magic happens because now I don't have to restart or wait for anything anymore. Everything I save is automatically there and it's instantaneous. So if I open my browser, and I'm going to close all the other tabs. 8080/hello, yes, it's returning. So for our demo, we want to connect to a database because that's the best approach that I found to see how having blocking I/O doesn't scale. So we also do some performance testing here on my machine. And let's try to create an entity. So developer.java, it's going to be a persistent entity. I hope it's big enough now. And it's going to add at entity extends Panache entity. Just in case you're not aware yet of what I'm doing with Panache, there are other sessions about Quercus today. And I also presented a workshop on Wednesday. But I'm just going to use the basic style with Panache. So I have a persistent entity. So I have all the query methods. And here I want to return return string. Let's create or reuse this endpoint. It's going to be /developer. And we're going to list developer. Change that to developers. Return developer.listAll. So fairly simple for me to create a REST endpoint querying everything on my database. And the only missing part is that I didn't configure the properties of my database. I can do that if I go back here and use the template. So my database is SparkJoy, Java is correct, username SparkJoy, and password SparkJoy. Okay, that should be all that I need. So I just go back here to my browser, and I also forgot to change from text to JSON. Save the files, very important, and go back /developer. Okay, raw data, good. I'm returning empty because my database is empty. If I go back here to my database, Panache created the entity. So if I describe developer, I have here. So I'm just going to assert. It's going to be 999. Okay, so I have a developer. Yes, it's querying. So this is for the standard JPA part that you did forever. So let's keep it this way, but just add another property because I want two applications on my machine. So I'm going to switch the HTTP port to 8081. So still answering. So for this change in particular, oops, I'll have to restart. So I'm going to restart my Quercus application, but it's very good because now we're going to try to use the reactive one. So let's create the reactive counterpart of the one that I've just did. So we're going to use this REST endpoint. So I'll create another project with Quercus, from Red Hat developers. And this one is going to be the reactive. And what do I want to do? I want to use Vertex for the reactive part. And I also want to use the reactive MySQL client. MySQL and MariaDB, the protocol is the same. So I can reuse. So I only need these two dependencies. I want to generate my application. Yes. And we should be good. So I'm going to unzip my reactive one. So let's open another project with VS Code. You can see that I have the same file that was generated before. It's a synchronous JAX RS endpoint. So first, I'll use the most different way. So I'm going to create some endpoints using a toolkit called Vertex, which, by the way, is one of the first reactive toolkits that we have in the Java platform. And it happens to be, if you go to any performance benchmark on the internet, it's by far the fastest web framework that we have on Earth. And not just comparing to Java, any other technology. So I'll start with Vertex. But then you see that since I'm using Quercus, I'll be able to blend Vertex primitive with JAX-RS, with async data sources. So we start with the weirder part, and you see that in the end, our code will be not that different. We'll just change some imports and changing maybe somebody will call, but it will be very close to from what we're used to doing in our daily activities. So I have this REST one. So if I just change this guy to, let me keep it this way. So I have a path. So what I could do, I could say public void developers, routing context. I hope I imported the right one because I always miss that. Root. Path is going to be /developer. And suppose the context, I imported the wrong one, of course. I never know which one is the right one. So I suppose it's the other one. Response, and for now, let's just test if it's working. So let's return developer. Okay, so I forgot to start the magic, Quercus colon dev. And go back here to my browser. Localhost 88/developer is returning a plain string, okay? Unfortunately, the missing part that we have in the reactive part is that there's no JPA API for reactive. So if you want to use JPA, all of the goodness of JPA and Hibernate, you're stuck to a synchronous, to a blocking data source driver. So for the purpose of this demo, I'm going to do some database magic, but in the hard way. So I have to connect to the database, fetch the results, and then map that to an entity so we can have some similarities. So I can't use Panache, but just if anybody asks, there are people working on Hibernate RX. So you will be able to use Hibernate JPA on top of an asynchronous database driver, because async or reactive JDBC doesn't seem to be happening anytime soon. So let's create this class, developer.java, which will be the same that we have in another example, except that this is a POJO. And for this one, I'll have to generate the getters and setters. Get ID, get name. And let's create a constructor because it will be easier for us to use it later. And since I'm not changing, I like to show that it's always a best practice. If you don't intend to change anything, just declare the fields as final. So it's another best practice. So I don't need a connection pool or something like that. I need a reactive pool. So right here, I'm going to inject my SQL pool, and I hope, which is my reactive database client. And I want to use this guy here on my method. So let's try to create a static method so it can be as similar as the other example using Panache. So the first structure that we're going to learn if you want to be async is from the JDK, we're going to use a new class called completion stage. What is a completion stage? Completion stage is any step that you have when performing an asynchronous computation. So your asynchronous computation can be composed of multiple different parts. And when you define everything inside the completion stage, then you can use the completion stage primitives to be composing all of the steps one after the other. Who here is used to the Java 8 Streams API? Okay, so you know when you have a stream, usually you get a stream, then you use perform operations, for example, like map, okay, or flat map. then you can collect, or you can use a for each. So what you're using, think about completion stage as the async equivalent of using streams. So if you have a synchronous stream, like in the Java 8 API, using streams, but it's kind of the same thing if you're using a completion stage. So you can compose, you can, well, have a completion stage, I can map that, well, there's a method for that. I want to consume that, then you can consume that using a method. So it's kind of similar thoughts. And this completion stage is going to return for me a list of developers, okay? And for here, I'm going to pull, which is my client. Okay, so return. And how does it work? Well, this is Vertex terminology, so I have a query here. So I'm going to select ID and name from developer. And this thing is going to return, surprise, completion stage. Okay, so what does it return? It returns, hopefully my ID will, because there's a lot of, oh, come on. I can to local variable. So, no. It's going to be a completion stage of a row set of row. Okay. I hope I did everything correctly. Yeah, surprise. So I created the query. So with this query, I have to transform that. So with the result, I can then apply. I want to transform. Remember the map operation streams API? Then apply does the same. I want to transform a row set of rows into a list of developers. So I get this row set. And what do I get? I get, we'll create a new array list of the size that I already have. So we're going to list of developers. Okay, and I have to import the right array list. Now I'm going to, the result is return developers, which is empty. Now, so let's populate this thing for row. In my row set, I want to developers.add new developer. And I'm going to get the row.getLong ID, row get string name. Okay, if I type it everything correctly, yeah, my code should compile and my job is done. So this is a, instead of using Hibernate, I have to do the mapping by myself, okay? And that's a restriction if you're using Reactive. For now, you have to, if you want to be pure reactive, you want to do that because, well, Hibernate RX is not ready. So that's the first question. If you want the traditional productivity that you have, you still need to stick with the imperative programming that you want. If you want like raw web performance, then reactive, maybe it's the way. So you need to know that you have to do these trade-offs. Database access, for example, is still a manual approach. You still need to do this kind of mapping. And I can return this guy. Okay, my code, hopefully it will compile. And what can I do here? I can say that let's get the developers. And so what we're going to do, I want to say that developer, I forgot to type static. List all, I'm going to pass the client. This client is going to return a completable feature. And when you're thinking about the code, when you're used to imperative programming, we expect that when your thread is going through that line is going to be executed immediately. A completion stage is a glamorous, is a gourmet callback, which is something that it is going to be executed when your operation is ready. So you're writing something that will not be executed now, it's going to be executed in the future, okay? But for the matter of business application, It's like when you're writing code that is going to be executed in an anonymous in your class. It doesn't make any difference. It will make a difference at runtime, but when you're writing your business code, it doesn't matter. So what you can do, I have developer.list all, and it might take some time because it could be a super slow query. But when you get the result back, you're not waiting. Your thread is performing other stuff. When the thing is done, you can then decide, well, then I have the list already. Then you can accept, and with this list, I get my developers, I can perform this operation. And when I perform this operation, I can say that, oops, I can get my context back, and instead of returning just developer, I can print that using JSON. Encode, and I'm going to encode my developers. Okay? Not before, and remember that it's just everything is raw. If you want to be super fast, super high throughput, it's kind of raw. So I'm going to put the header saying that my content type, it's also application/JSON. Okay? If I did everything correctly, now I go to developer, I'll get the same result that I had on my imperative application. So go /developer. Which is taking forever. Well, it's not supposed to be this way, it's supposed to be fast. What I did wrong. Luckily, I thought that things could go wrong, so I have another project here, which is ready. Go ahead and developers. No, I have a second screen, sorry. I don't want to see me cheating. And if I go back here, so let's compare what we have here from the other one. Return developers. This one is right. Maybe I'm missing the other file. Example resource. So my endpoint here should be developer.list all. It's returning a completion stage. Then it should be then accepts and JSON grunting code dev. Everything seems fine. Yeah? Maybe nothing that I restart doesn't solve. Should return. Okay. Developers list all. This one. Oh, here the signature. Okay, no, this is different. This is the Vertex way. All of the processing happens with this object. So it should return void. But later, don't worry, later we'll change, so it will return something and it will work. So I'm using the hardest way, so you can see how easy it can be later. Okay. It is a feature. I did all of this. How the hell my application know where is my database? If you don't say where it is, well, it will never find it, okay? So, nobody was paying attention, damn it. So now I can go here and where are the properties? So I'm going to cheat, you use a template. So this is the same data source that I configured on the other application. What changes is the URL. I'm not going to use JDBC anymore. I'm going to use the Vertex driver. So I'm going to use Vertex-reactive. And I'm going to type my SQL. And the rest is OK. Localhost and database Spark Joy. There is no need for a driver because I'm not using JDBC. But the username is Spark Joy. The password is Spark Joy. And database generation is also update. I'm also going to tweak because I want to perform a performance testing later so we can compare. And Vertex is so efficient that he uses a very small thread pool, but I want to have the same results on both applications. So I'm going to tweak that to use 5, okay? So on this application, I'm going to use 5. On this other one, we're also going to use 5 because we're going to try to overload. And if I use 20, which is the default, it takes forever for me to end the performance test, okay? So both have a 5, and now that I configured it properly, now it's returning, okay? So both applications are returning exactly the same result. Now let's go back to our imperative application and write some business code. So later we'll try to map this business code into a reactive counterpart. So developer.listAll. Well, in the real life, your methods are not that simple. You have to perform a lot of things. So for example, maybe if you were trying to insert something in your query, you would check if the user is authorized, or you're not just returning your plain entity. For example, you're returning here in your REST endpoint, you're returning the ID of the customer, which is a bad practice. You should not expose your database IDs to the web. Maybe you need to expose a business ID, and you should filter this field out. Okay, but we're exposing because we have the raw entities, and maybe you don't want to expose everybody. You want to just only show part of the developers, for example. Maybe you want to do this filtering in codes rather on the database. And I'm saying that we're going to code this use case because it's simple enough to fit in 50 minutes. But in real world, it's just more lines of code. So first, what we want to do, let's try to create another class. Let's try to create a DTO, which will simply Java, which will be a class that only contains the name. So name, it's going to be final. And don't worry, I'll be copy-pasting this class on the other project later. Developer DTO, string name, receives name. And just because of the JSON APIs that we have today, I need the getter. So I have a DTO already. I go back here and say, first, I want to filter this thing. And if you use the Java 8 Streams API, that's not the way that you would manipulate lists or collections. But think about this code as your traditional business application code. And usually, well, what you do is that you have a piece of code, then you get the result of that piece of code, you assign that to a variable. So this variable is used on the next step of your code. So later you can refactor this code in smaller methods. So that's the kind of refactor we're trying to do, because that will help us a lot when we're trying to change that into reactive primitives. So what do? We have the developers. So first, I'm not returning that directly. I'm going to get a list of developer. And let's call this guy's developers, which is the first list we're manipulating. And developer, if I can type that correctly. So I'm returning, suppose that I want to transform that to a DDO. Okay, what would you do? You would create a new list. So you have a new list, which is DTOs. It's going to receive a new array list, which is developers.size. And you're going to perform a for. And remember, I'm doing everything the hard way for the sake of simplicity. And we're going to get DTOs .add new developer DTO. And we're going to use the developer.get.name, since we're using Panache. Okay, array list. DTOs.add. Oh, the DTO, right. Now you're paying attention. And return DTOs. Okay? Developer DTO. I performed my change. If I stop this one, let's open another tab and go to my imperative code. I can go back to localhost 8081/developer is only returning Yanaga. Let's perform a very quick test here. So I'm going to use a load test called Siege. going to have 20 concurrent users, and each one of them is going to issue 5 requests to my endpoint, which is localhost 8081 developer. So it takes, oops, wrong parameter, 5 requests each one. So we're going to run, and it returned 100% of the requests. Okay, because I didn't load that enough. So if I get my cheat here, cheat, siege 25. So let's try to increase that until we have errors. Why is that so fast? Okay, it's mocking me. Oh, come on. 2,000 words? Okay, now it's giving me errors, okay? Because I had a lot of concurrent requests, and I should be seeing some, come on. Okay, 30 minutes ago, when I performed this test, I would see a lot of database connection errors because we have a thread pool, which is connected to the database, and when each one of the requests comes, try to get a new pool from the database pool, but of course, everybody's busy. Now I know. I forgot to make it slow. That's why it's performing so well. In the real world, your database doesn't perform this way. So what I'm going to do, I'm going to cheat. Sleep, and we're going to use formula, and it's going to be sleep for 1 second. Okay, formula, and it's going to sleep for 1. Then my initial testing should be enough. Yeah, it was 1. Okay, it's running. So let's put siege to work. Yeah, now it's taking forever. So which was the goal? But if you process, you can see that I have here 11 connections. Well, the ones that I'm using are these ones. They're performing in sleep, and that's why it's taking a lot of time to process. So here I issued 100 requests, and 5 of them failed because we didn't have enough database connections available to perform the request. This is if using the imperative, and I only sent 100 requests. Now imagine in the real world it would get much worse. So that's what you get when you have imperative code. There's a certain threshold in which above that, you won't have enough database connections to the database, and you get errors in your application, which is exactly the exception that I'm getting here. Now, suppose that we want to try to do that in our version that is reactive. You will see that let's try to stop this imperative one and perform the one with the reactive. I'm sorry if I'm not coding the DTO on the reactive one because we're running out of time and I want to show the business code later. So if I go here to my reactive part in developer, if I want to tweak that, I just add here another field. On my query, now it should be slow. So go back here, run the reactive one. And run siege again with the same parameters. Oh, wrong port. So now I'm running siege, and beware that when running siege is going to take a lot of time because all of the transactions will be successful. And I'm running 100 requests, so if each one of them is going to take at least 1 second because of the sleep, it's going to take more than, almost 2 minutes to run this load test. I don't want to wait that at all, so I'm going to stop the test right now. But you can see that it served 73 requests for now, and all of them were completed successfully. Okay, I have 0 failed transactions. So that's what you get when you have a reactive part. So what can we do here? Suppose that now I go to back to my code, business source code. So this is imperative. How can I translate this thing into the reactive way so we can reuse our skills. I have here, and I'll just tweak here. Let's create another list. This one will be of developers, too. And I want this to be a filtered one. Okay. And on the filter one, I only want to provide for developer in all developers that I have. If developer.name starts with y, I get the filter.add developer. Okay? And here in the DTO, I want to use the filter one. And the filtered, and we should be good. Okay? So this is all business code. And what can I do to be able to compose that into a synchronous step? Suppose that each one of those steps that I'm using, filtering and then translating to DTO, could use some kind of I/O, could be connecting to a database and performing a query. So they're all I/O bounded. So you should never wait for an expensive computation to stop. All of these should be mapped into a separate completion stage, because then they can be executed asynchronously. So what we can do with this code, we can get this stuff, source, refactor, and choose all of this, refactor, and extract methods. So we call this mapped filter. We can get all of this code, refactor, and extract that to transform. Okay? So we created two business methods, which is a good thing because you can test them separately. We created a method called transform, and we created a method called filter. And this is our imperative traditional business code, which is not, well, you perform something, returning to a variable, you get the same variable, you perform in another methods. It's common, right? That's what most of us do every day. So how can I use this code that I just refactored into my reactive primitives? I'm just going to pick this code, copy paste into my reactive part. Yeah. What is the difference? I don't have class developer DTO, which I'm going to copy paste. I have developer DTO now. I have developer resource. Import the right ones. Array list. And here I'm using a name, so let's change this. Get. Okay, so I have transform and I have a list. And here, instead of returning list, the old object, I'm returning what? Completable features. So I have to apply these operations in completable features. So when I say developer.listAll, what do I have to do? Then accept, then apply, because I want to transform a list of developers into a filtered list of developers. Then apply, filter. Okay? And then now that I filtered, I want to do that. I want to do what? I want to transform that things to a list of DTO. So this, transform. So now my code is 100% reactive, 100% performance, yet I'm reusing the same business logic that I had in my imperative code. And if I did everything correctly, my reactive is running. I can go back here to my browser on port 808080. And we return null. What did I do? One at a time. 3. Oh, yes. I knew that. Perfect. Right? Thank you very much. And so it's working. So, and if you think, this is exactly the way that you would be using if you were using the Streams API here on the other side. Right? I have my business code. Here, in the real world, you wouldn't be doing all of this. You probably would be using the Streams API to be able to execute these steps using lists, for example. But I wanted to do this way because traditional business code, most of the times you can't use the Streams API. What is the only shortcoming of what I've shown you today when you're trying to blend, transform imperative to reactive? To be even closer to what we used on the Streams API, completable features, they're not aware of the type they're manipulating. For example, my completable feature on this code, even though the completable feature is returning a list, is not aware that a list is a collection of objects. So I have to write my method here saying that, oh, I have to iterate through each one of those items, even though I'm still returning a list. Okay? So what does it mean? Well, completion stage and completable feature, they're not aware of collection cases when they're manipulating the internal value. Okay? What is about to change? We are developing a new API, a new project. If you go to the Quercus website and check out the source code, there's a new project available there. It's recording, I'm not sure I can say the name. But there is a new API over there which will get these features of completable features and completion stage. And we will add the capabilities it's a different name of the methods and classes, but we will add the same methods that you used with the Streams API. So instead of having to write then apply, you would write map. If you want to manipulate something in the list of lists, it's not going to be then apply, you're going to write a flat map. If you want, then it's going to be consume and all of this kind of methods. So it'll be even easier for you to get your business old imperative code and translate that to reactive APIs, okay? And that's part of what I wanted to show you today. I hope it was enough for you to have a glance of what is possible to do reactive APIs. It's not a completely different word. You can reuse your existing logic as long as you're composing your business logic in smaller functions. So you can map that to completable feature words or any other reactive API that you have. Thank you very much for now.